Hey, Hunter. Hi, Aaron. Hi, Manas. That's you, Hunter. Huh? That's good. It's okay. It's okay. Hunter, how are things on Molokai? Is it raining today?
Oh, a little bit. It's pretty hot today, actually.
I'm very excited. We've made all our family bookings for December to come out to Big Island, the Big Island, and then Molokai. Manas, tell us where you're connecting from, please. And same for you, Aaron. If you could please unmute and tell us where you're connecting from, that would be great. I'm going to turn off my virtual background so you can see the others. Sure, perfect.
I'm from the Bay Area.
Oh,
San Jose, actually.
Oh, so you, Manan, you were part of SIP then?
Part of what?
The SIP program? No? Were you part of the science internship program at Santa Cruz?
No.
No, okay. Which school do you go to?
I go to Lee High School.
Oh,
it's a STEM school, yeah.
I used to live very close to there for 16 years. Lee High School is at the corner of Lee and Los Gatos Almaden.
Yeah.
Yeah, I used to live off very close to Union and Blossom Hill.
Oh wow, that's actually really interesting. The road I live on is right off of Blossom Hill.
I see. Small world. I learned to rollerblade or rollerbleed, as my wife called it, in the parking lot of Lee High School. So small world. And how about you, Aaron? How did you find out about STS and what connected you to us? Aaron, I see you're unmuted, but we're not hearing you. Try again, or maybe disconnecting and reconnecting. Over there, we hear you. We hear you. Go ahead.
I got into contact with a mentorship for my senior legacy project, and she sent me a link to this to see if I would be interested in learning about the process behind gathering information for astronomy.
Okay. Do you go to which part of the world are you in?
The Big Island.
Big Island.
May I ask a question, Aaron? Are you talking about Julia Swartzer?
Yes.
Yes.
What a small world.
I'm working with Aaron. Yes. So Julia Swartzer, yeah, we're doing mentoring. She's mentoring Aaron on his senior legacy project. In fact, I just emailed Julia about stuff for you for next week, Aaron. And yes, I suggested this program. I thought you might like Shadow the Scientist as something to get you more interested and more experience with the whole community. So I'm really glad to see you here, and I will definitely let Julia know that you came, Aaron.
Which school do you go to, Aaron?
Kamehameha Schools.
Oh wow, fantastic. Okay, so we're on the Big Island right now. We're in Waimea, the four of us, and I'm going to share my screen so you can see what's going on the telescope. Okay, just a moment. That'll take me a minute. While I'm doing that, why don't we go around and actually, Manas, you said you're in Lee High School. Which grade are you in, Manas?
I'm a junior this year, 11th grade.
Have you heard about the science internship program?
No, I actually haven't.
Okay, so that's something we run at UC Santa Cruz. Antara can tell you a little bit about that. Also, I want to introduce you guys to Hunter. I met Hunter in person for the first time last weekend. Hunter is at Molokai at the Akaula School, connected through Shadow the Scientist initially and through Ohana Kilohoku, which is an organization in Hawaii. So anyway, we're all connected. Let's go around and have, Hunter, do you want to say anything by way of introduction for yourself? Go ahead.
Sure. Hunter, I live on Molokai, go to school. Time at Raja. He came to my school and gave some presentations. And yeah, I'm here to learn about space.
Wonderful. And Hunter, you have a younger brother who's also interested in space. And I know he was asking great questions the other day. Let me see if I can find my right X term here, where I can run. Oh, there we go. This is the correct one. So what we're going to do is I'm going to run a virtual network session where I can look at all the windows that are being used to control the Keck telescope and the instruments on the Keck telescope. And as soon as those are up, I can share my screen. Why don't we go around and do intros here while we're doing this? Jamika, you and Stefan are our guests today.
Oh, well, aloha. My name is Jamika Marshall. I am currently an outreach assistant at the International Gemini Observatory, which is a program of NSF's Lunar Lab. I've been working with Brian Lamone, one of our astronomers at Gemini North, to bring Shadow the Scientist to Gemini. So I'm really excited to be able to join a live session, not just watching the session, but to join a live session. So I'm here to contribute how I can, but certainly to take notes on these amazing best practices. Thank you for having me.
Rico, welcome. Stefan, we have been working together for about a year now. I met Mailani in person a year ago. And
actually drove to school. That's why today. Yeah, so my name is Stefan Kimura. I'm a graduate of Willamette University. I graduated with physics in 2018. I got into contact with Raja through Sam and Maunakea as well. So that was really helpful. I've been working with part of this salvation team for the last year or so. So I've been learning to kind of take astronomical data and reduce it. Now I've done a few nights running the telescope at the Loop Observatory at my home.
And tell Jamika, tell Jamika who your mentor is. She knows your mentor.
I worked with Andrea for a while.
Andrea Project.
Yeah, I worked with Kimura. I may have met you at some point through there.
No, but there's another person you guys have in common who's a Gemini staff member.
and Maunakea.
It's a small world. By the way, this is one of our RLR that they just observed, this star. So for the folks on Zoom, I know we have a very small group on Zoom today. In the past, we've had bigger groups, but so let me share my screen, and others will, may join later. But we're recording this session. I'm going to share my screen, and we can talk about what you're seeing here. I'm sharing it with sound, so that when you hear sounds from the telescope, and I hear sounds from the telescope, you'll hear them too. Just a moment. Let me navigate my way back to where I want to be. There we go. Slow loading, but it's okay. So there are 4 windows here. This is called Control 0. Please, Hunter, Aaron, and Manas, please speak up if you can see this, what looks like a complex mess of screens. You feel like you're a fighter pilot in front of a bunch of controls. Can you see that?
Yeah, I can see it.
Oh, very good. Okay. So at the top, you see it says Control 0. So this is one, this is 0 index. This is Control 0. This is Control 1. This is Control 2. And the final screen is called Tel status, which is the status of the telescope. So from this, I can tell that the last thing it took a spectrum of was this thing called PS1 223142. This is a kind of star called an Aura Lyra, a pulse. And they were discovered, this particular star was discovered in the Pan-STARRS 1 survey telescopes are in Maui. So Pan-STARRS 1, and the ID is 223142. It's a 13th magnitude star that pulses. And in fact, the star right now is sitting inside this slit. Can you see what looks like a tiny, if you can see my cursor, you see these 5 cuts in a piece of metal. And that's why these cuts are dark. And the rest of the metal is mirrored. So it's reflecting the brightness of the night sky. So is this lower part. But these cuts are cuts in the metal where light goes through. And there's a light of a star. If you can look closely, there's a light of a star that's going through there. This star is being used to guide the telescope to make sure it doesn't drift. And that star
Exposure complete.
just completed an exposure of that star. And you'll see now it's reading out. It was a 5-minute exposure. Now it's reading out. And in this window, when the readout goes from 29, 31 to 100%, it will show us a spectrum of the star. And I'm going to quickly pop in there to ask those people if I can, for a moment, play with the, I'm in view only mode. If you go up here, you'll see I'm in view only mode, but I want to go into interactive mode. So give me a moment. And Andrea, you have an introduction.
Sure. Hi, everyone. I'm a sophomore in college at Harvard studying astrophysics, among other things. And I've been working with Raja for
DCD readout complete.
4, I think at least 4. But yeah, I started working with Raja in school. The SIP program that Raja mentioned, I was an intern in 2019 and a mentor in 2020. Great time, highly recommend it, but I work on classifying and we discovered this very interesting kind of star that has interesting chemical properties, and I work on basically characterizing that kind of star and trying to identify it in all the spectra that we have for the Andromeda and triangular galaxies. But yeah, that is one of my main projects with Raja. And yeah, I am very excited to see what this looks like. Yeah, until Raja returns from doing stuff, does anyone have any questions that any of us potentially could answer? You can put them in the chat and or speak. And I will also put the link to the SIP website in the chat.
Good idea.
I
do.
Yeah, so especially Manas, because I know you mentioned you're a junior and in the Bay Area, which is where SIP runs. I'm not from the Bay Area, I'm from India, but I did SIP remotely before everything went remote for COVID. And they still let me do it, which is incredible. But that is the SIP website. And yeah, feel free to check it out. What I did during SIP was work on the early stages of one of the projects I was talking about. What we were trying to do was I used the spectra of the star to use the spectra of stars that we knew were of this interesting new type that had interesting chemical signatures that I can talk more about if I'm interested in. But we had a small population spectra that we knew were of this kind, but we had a data set that was like 30,000 stars. So I was trying to automate classifications of those stars during the first SIP project. And then when I was on the second SIP project, what we were all doing was trying to expand that analysis, which we've been doing in the Andromeda galaxy to the triangular galaxy. And now we're working on other galaxies, including the Large Magellanic Cloud. So there's a lot of fun galaxy stuff happening. But yeah, SIP is a good program. I really like it. Alessandra's here. Alessandra's here. Still connecting to audio, and that sounds like that. Hi, Raja. I've been talking about SIP, and I put the link to SIP in the chat.
Very good, very good.
Yeah.
Very good. A best spokesperson for programs like this.
Yeah.
And you've drunk the Kool-Aid. So they said it's okay for me to go to view only, and Alessandro is going to be joining the Zoom call. He's here. Okay, so that way he can, if he wants us to not move the thing, he'll chat or tell us to lay off so that he can do stuff with the where is it? If he wants the controls back. So this is our star. And I wanted to show you something. So let me zoom in. Oh, okay, it's reading, it's showing up. My computer's still being a little slow, but it's not too bad. So this is an RLR that Alexandra has just observed for us. And I'm trying to see is being so slow. It's my computer being slow. It's not, it's the internet that my computer's internet connection is being slow for some reason.
Did you say we're looking at an RR Lyrae star?
This one.
Okay, I don't know if Aaron is familiar with RR Lyrae stars. I don't know the other people too much.
Please explain. Please, you should go ahead. Absolutely, go ahead and explain what they are, or one of us can do that if you prefer.
Yes, actually, would one of you explain what RR Lyrae stars are? I know you probably do it very precisely.
I'm happy to do it.
Okay, I think
So I'll be happy to do it. So the sun won't become an RLR star, but other stars that are similar to the sun, but that are more chemically, less chemically enriched, so lower iron to hydrogen ratio than the sun, when they become, after they go from burning hydrogen in their interior, which is what the sun is doing, the centers, that's called a main sequence star, that's what the sun is. Then they become red giants when they're burning hydrogen in a shell around an inert helium core. Once all that is done, then they start igniting helium in their core and they become what I call horizontal branch stars. And some stars, not all, some stars in a particular temperature range go through pulsations. They go through pulsations, and as Yale was explaining this. Yale was explaining that what happens is they go through a phase where their hydrogen becomes opaque. H- ions become opaque to radiation. That happens, the nuclear fusion, the light from the energy from the nuclear fusion couples very strongly with anything that's opaque. That's what opacity means. It's blocking light. So that light momentum transfers onto the hydrogen, negative H- ions, causes the star to blow up. When it expands, the internal changes within the star, it actually gets hotter and expands, and the internal changes make that H- go transparent again. The moment it goes transparent, now the nuclear fusion radiation is not coupling as much with the hydrogen. Gravity starts to win, it starts to collapse. The hydrogen becomes opaque again, it goes through this. And the pulsation cycle is anywhere between a third of a day to 3/4 of a day. So a quarter of a day to 3/4 of a day, 6 hours to 18 hours. And so we're studying these stars because they're excellent tracers. Because they pulse in this characteristic way, they're very easy to see throughout our galaxy. And yeah, please do. I'll stop sharing my screen.
Exposure complete.
Yeah, please go.
And were you going to say that RR Lyrae stars would get tracer of?
No, they're a good way. They're easy to spot because sorry, I have my back to you. They're easy to spot because of the way they pulse. But the other property they have is even though they pulse, they have some average brightness. That's the same from one to the other. So they all pulse. They have different amplitudes of pulsation. They have different colors. They have different temperatures. If you time average their brightness, especially in something like the I band, they are standard numbers. They're all the same luminosity. So these two factors, the fact that they pulse like this and the fact that they all have the same intrinsic brightness,
PCD readout
makes them
complete.
excellent tracers. So they pulse like this. The brightness on the y-axis and time on the x-axis. Time measured in units of period. Sure. Yeah. So I want to give an analogy, which is when you look at imagine you're sitting outside you're sitting at in your apartment in New York City, you're looking out of your window, and there are lights all through the city, right? Street lights all through the city. It's impossible to tell which light is close by, which light is far away, right? Because they have different intrinsic power. And in astronomy, that's a huge impediment. Knowing how far away a star is hugely important. Now, you notice that in the apartment building across from you, across the street from you, where you've visited many times and you know how far away that building is, you notice that there's a group of stars that are pulsing, group of lights that are pulsing, going up and down with some frequency. And you notice that all of them have the same time average brightness. You know what that brightness is because it's in the building across the street from you. You know how far away it is, you know how bright they appear to be. In that analogy, if I'm using that analogy, that could be a globular cluster in our Milky Way. Go to a globular cluster, you know how far away it is, see a bunch of globular, you see a bunch of RLR that are pulsing up and down. You notice they all have the same brightness, they're on the horizontal branch. You can show that in an HR diagram. You see that they all have the same luminosity. This is the horizontal branch is C on that one.
I can pull up.
Yeah, I would pull up. Yeah.
Is the horizontal branch the same as the asymptotic branch?
It's different. So it goes from the horizontal branch up to the asymptotic giant branch afterwards, right? So this also doesn't show the, yeah.
I can just search.
Just look at a globular cluster CMD and you'll see it there. So because it's an old population, what this is showing is young and a range of ages.
There we go.
Yeah, there you go.
Yeah.
Any one of these will show it.
This one has all the.
Yeah, so that's the horizontal branch. It doesn't look very horizontal, but you know, in other clusters, it could be more horizontal. You know, like you can see that in the M15 one. Yeah, this one has it all labeled. You're right. So, so the building across the street, the analog for that would be a star cluster in our galaxy whose distance we know, and we notice that all the pulsing stars have the same average brightness, and we can calibrate the luminosity with this cluster whose distance we know. Now this becomes a tool. Now, when it's in, you're still sitting by your window in this New York City skyline, and you notice there are stars in the far distance that are also pulsing. They're very faint, they're pulsing. But now you know from the building across the street that those pulsing stars, you know exactly what their wattage is, the 100-watt light bulbs on average. And so if you know how bright they appear to be, you've got their distance. So it's a great thing for mapping out because they can be spotted easily relative to other stars because of the pulsation, and they're standard candles in that they all have the same time average brightness. So they've become very important tools for studying the structure of the Milky Way. The student I'm working with at Santa Cruz, Yuting, has found what is literally the most distant stars in the Milky Way. So redefine the size of our galaxy. Hello, Chensu, how are you? You're running shadow again today. So Chensu is a close friend of Monica's. Shavika, Chensu used to be at NOAA lab in Tucson.
Oh, really?
It's a small world.
It is small. I'm at Juna. Yeah, nice.
And she works, she knows Monica well. I was supposed to meet Monica today, but she's unwell in Hilo. I was in Hilo earlier today.
Yes. Also
Rainy.
Good to meet you.
So many connections, really wonderful connections. Where are mine? Okay, so that's okay. Yeah, sure, whenever. Turn off. And it's often referred to as MSTO, main sequence turn off. So basically, when it first starts to exhaust the hydrogen in its interior, it peels off, starts to become a red giant brown star. And that horizontal bit, let's see, we go back to this. So this horizontal bit is called the subgiant branch. Then this is the red giant branch, RGB. And so they go from the tip of this, where they start burning hydrogen, they go straight from there to HP, and then they make these pulsations up here. That's the HB, asymptotic giant branch. We are hilarious somewhere here in this part of the HP. Not in the far right. You see a little enhancement there? That's actually the continuation of the HP right there. if you go to one of these other ones, you can see the horizontal branch as can either be way off to the left, or it can be close to the RGB, or somewhere in between. The R and the RLRA are in this part of the horizontal branch, the sort of middle part. Not too hot, not too cold, sort of like Goldilocks' porridge.
And is the WD there?
White dwarf, yeah. White dwarfs, exactly. So I wanted to, Sandra, can I share the PNCs now?
Yeah.
Hi, Alessandro. You can't hear us, okay. Because he's got our sound turned off. Brian said,
Exposure complete.
Brian's on his way. 15 minutes. Manas and Aaron Hunter up here. Oh, thanks for sending this thing. In fact, Subika was mentioning that CREST is a thing. It's crest.ucsc.edu. That's the umbrella program. And SIP is SIP.ucsc.edu, and then the Python thing is called PYAR, PYAR for Python and Research. .ucsc.edu. It's all UCSC programs. But looking for the
The readout
Bollywood, every Bollywood movie has a PR in it. Yeah, we do have a website. Yeah, press. We have wonderful websites now. Thanks to all. It was just a Google Doc at one point. So this is one of Alessandro's RLRA that they're about to read out. But in the meantime, this I believe is H beta.
This is a binary, actually.
It is? Wow.
Yeah, it's not an RLRA.
Okay. Why is there? Oh yeah, okay. It's reading out. How bright is it, Alessandro?
10.8, I think, but we have 1.5 magnitudes of attenuation tonight.
I see. Let's see. Let's see what I will remember. It is a message.
I can. Yeah, it is.
So he said it's not an RR star. It's a
Movie
it's a
star.
binary star. So you didn't know that before we were looking.
So he switched targets. So it was the spectrum we were looking at before was an RLRA, but in the meantime, he's taking a spectrum from the star. So because of the clouds, we're not doing our main program. We are looking at bright stars. And he has some favorite bright stars. I have some favorite bright stars. Back and forth between them. So the RLRA are relatively bright, and these are Gaia targets that are also relatively bright. So what's the threshold? Depends on how much. So he said there's 1.5 magnitudes of extinction. What that means is things that are 10th magnitude appear to be 11.5. He's looking at things that are 22nd magnitude, and clouds are going to make them 23, and that's just too faint to be worth looking at those. The things I'm looking at are 12.5 to 13. So they become 14, 14.5. And that's still very easy to do over the telescope. So you're looking at sort of our bright secondary bright target backups. So that- Yeah. I think and we were taking long experiments. Yeah. Here, when we're looking at 13, 15 magnitude, 7, 10 to it's not so. You should see the model of the Keck telescope there and actual photos. Right. So, so and then crest you got already. Crest, you see it's an umbrella website because it talks about all the other ones. And it talks about that structure of depleted water. It talks about all of that. Oh, yeah, another connection. Wonderful. Hey, Rita.
Hey guys,
How are you?
not bad. Figured I have maybe a couple of minutes here to sign in and say hello.
Rita, please go ahead and introduce yourself. We have a few people who have connected from different parts
Yeah,
of the
sure. Fair warning. If my observer needs to do stuff, then I will disappear.
world.
But hey, my name's Rita. I'm tonight's telescope operator. So I'm actually up at the summit right now. I'm maybe the only one that's up at the summit right now. I've got a night attendant in the other room, and that's it. I think you guys probably can see Tony in the other room. He's working remote from Waimea today.
Oh, okay. He may be in Remote Ops 1 then. I haven't seen him in Remote Ops 2.
Yeah, he should be there, but I don't know.
So we have,
Anyways, I'm up here at Keck II, so
thank you
yeah.
for doing what you do.
Yeah.
Rita, we have Hunter from Akaula School in Molokai. We've been connected to the school through one of their teachers. They've been frequent participants in Shadow the Scientist. Aaron is on the Big Island of Hawaii. He's in Hilo.
Oh, he's in.
Not Hilo.
He's in Hilo.
Where's the
It's just Seattle.
It's
Close. Okay, so north of Hilo, south, on the way to Volcano. Okay.
Yes.
And then Manus is in the Bay Area. He's in a school in Los Gatos, San Jose area.
Very cool.
And of course, you know, Alessandro and Stefan here. Stefan is based in Kona, and we were connected about a year ago. He's doing research with our group. His primary mentor is actually based in Hilo at Noir Lab in Gemini North. Antara, you've met before, maybe yesterday. She's an undergraduate at Harvard, a sophomore at Harvard, who started working with our research group as a high school student, and you know Jamaica. You know Jamaica already, right?
I do.
Yeah.
It's kind of interesting to see you like not in person for a change.
And we have a very small group today
Yeah.
on the Zoom call Friday night after all. And our big group from India that connects every night is not able to connect today, but they'll be back on Sunday night when it's Monday morning over there. Because we're running a series of 20 STS sessions, we've had a limited number per session, which has made it wonderfully intimate. We've been able to answer personal questions. Ivana's here. How are you? Not at all. We're just running a shadow session. You know everyone here? No. You don't know. You only know me in this group.
Yes, well, hi, I'm Ivana. I'm a postdoc at Raj's grant.
You should introduce yourself to Ivana. You just got it.
Yes.
Okay. So we are running this shadow session here.
Very cool.
What was that, Rita?
Very cool. Glad everybody's here. And it's nice to have a small group
I
for a
flew in
change.
from New York, so it's quite late.
So at various times, Rita, we've had school groups from Africa, various countries in Africa, Ghana, Malawi, Zimbabwe. Various times we've had school groups from India. We've had groups from Mexico, different parts of Monterrey, Mexico, Sonoran Desert in Mexico. We've had students from all over California, Hawaii. So today is a quiet night for Shadow the Scientist, but often there are many more people. It may be
That makes it more fun, right? That means that you get more kind of, I don't know, time to explain things and whatnot.
It's much more, there's much more one-on-one discussion in these small groups. Rita, how long is your shift on Maunakea? How many nights? How many more nights?
So this is night 2 of 4. So I'll have 2 more nights and then I'm done for a week or so.
Okay.
Which is nice.
Complete.
Hang on, I might have to disappear here.
No problem.
And then probably you will not want to see me for a while.
Do we need to move the telescope?
Yes, we do. Thank you.
So it's about a magnitude and a half of extinction clouds on the mountain. And so this started around, the clouds started to roll around midnight last night, but was Tonight is Dan Weisz, isn't it? Yes. Alessandro, who's in the room over there, he's the first. He's right.
Yeah, I know.
He's, that's exactly where he is. So he is running tonight.
DCD readout complete.
So last night and tonight are Dan Weisz's nights. And then tomorrow and day after Marla's nights, but Dan is running these then. And then we are on Monday and Tuesday nights. We're thinking of driving up to the summit to everybody days. Alexander is also going to come with us, for us.
Yeah.
So if the only thing is, he'd want to get back for calibrate the instrument, so we have to go relatively early. And it looks like tonight's going to be much better wash in terms of staying lit. So if we could leave around 11, we could safely leave back at 4. So we wouldn't be able to go inside any of the doors. That's the thing. So we'd be driving up, but we'd walk up to the summit, see the lunar landscape. You could get up there.
Yeah, I think so. Yeah.
Okay. Oh. Wasn't paying attention to my. Oh, sorry.
Yes, I'm Stefan. I live here. Just put into contact with him with the Maunakea Open Group. So I'm hoping to go back to graduate school at some point, but right now just chilling.
You live in there?
I live about an hour down.
Oh, okay.
Probably drive down this.
Oh, yeah, just for a few years.
It's quite a drive.
Yeah, especially like.
Yeah.
Like I should walk. Yeah. I feel it's like.
Hi, everybody. I'm Brian. You're
Stefan.
Stefan? Oh, nice to meet you.
Aaron is on the Zoom.
Oh, Aaron's on the Zoom call.
Okay. And that is his mentor. Connected.
Yes. At Gemini.
Mentor is at Gemini? Aaron's mentor?
Yes, Julia.
Julia,
Yeah,
yes,
yeah, yeah.
Julia, yes, Julia had talked about it. So yeah, so
Small world.
Yeah, so it's.
awesome. I'm gonna use the restroom and I'll be right back.
Okay. Awesome.
Okay.
Oh, I'm so sorry. My name is Julie. Yes. So nice, likewise. And I'm connected to Brian. Excuse me,
Hey guys, I'm back again.
So, Brian and Janika are gearing up to run shadow scientists on few scheduled telescopes like why not? But what they're setting up will be a template for Devon and South. And the old telescopes, the old lab telescope, the 4-meter Blanco, the Mail telescope, LSST, CFHC is also previous, so they're waiting for this template to get off the ground. So classical nights are, this is a classical night. So we've got on classical nights so far on Subaru, Keck, K1, K2, and Lick so far. But we are about to, I think, start on Gemini North other telescopes. We're also thinking of other sciences, actually, which other sciences like oceanography and robotics.
So is the idea that
So we have two flavors. We have two flavors of shadow scientists. One where anyone can join, except we ask people to fill out a registration form. We ask a few simple questions about how they found out about this and questions, especially for coordinating other groups of students. So you see the registration form as a section for coordinators. And this was put there by someone who's evaluating the impact of this program. So it's a funded program. And we have an evaluator who's doing the work, understanding the impact of participants and scientists. But then we've got a few, not many. We've had to run more dedicated sessions. We say to a school group, particular community group, say, okay, tonight's STS session at such and such time is tailored for you. No one else will know about it. No one else will get registered. So we've done such sessions. We did a wonderful session with the Concat tribe in Sonora Desert. These two towns in Mexico, northern Mexico, Punta Chueca and Isabroque. In fact, they're from one of the two towns, and they're sort of rival towns. Because one has water, one doesn't. But they're frenemies, right? So what happens is the group that was going to join, they lost power on the night. We were on the Keck telescope. I was in New York City running it on BNC. We were on ESI, and Concord group lost power in their town. They went over to their frenemies in the middle of the night. Use their internet
complete.
Wonderful. It was a group of contact astronomy educators and their students. I was just them and no one else. And this was a connection made by professor at UC Santa Barbara in Chicano Studies, who works with the group there. She's doing social activism and access to water, things like that. So the astronomy connection with them is. So we've had sort of dedicated groups like that. We've had school groups in Malawi, Zimbabwe, where we have one Zoom connection, but there's a school, 30 kids in school. Last 5 nights, we've had a school group from India called Future Hope, Kolkata. They are, that school is, the children are extremely impoverished. The streets, some children were housed.
DCD readout complete.
And then they come to one school. Questions that they're being asked. Confidence, the comfort level. It's just fantastic. So they couldn't connect today because their homes don't have internet connection. Homes in their residential homes they housed it, but the school is out for Saturday, Sunday. So Sunday night. So this
Well, it sounds like, yeah, an amazing program. I actually don't think I knew that this until
many
it
hats.
showed up right now.
Yeah, many hats. Yeah. No, this is a string of 10 nights. where we have literally 20 SDS sessions. One of the first 2 hours of the night, 8 to 10, and 3 to 5. 3 to 5 people haven't been last few nice ones. Anyone sit and see the.
I've been sitting all the way from the university. I'm Brian, by the way.
Oh, sorry. Yeah.
Yeah.
Please come sit. That's the introduction. That's the introduction scene.
I'll hang out here.
Yeah, this is the introduction.
Yeah. Introduction. Cool.
Hi, everybody. I'm Brian Lamo. I'm a astronomer scientist at Gemini North Observatory, which is an observatory also on Maunakea, just about, I don't know, 500 yards. Let's see, southeast of Keck II. So 8-meter class telescope, and I am here to join Raja to observe with a different telescope tonight. So my primary interest is in galaxy clusters and trying to constrain how galaxies form and evolve in these giant conglomerations of galaxies, how they interact, how they run into one another, how their black holes get active, how they form stars. So a little bit further out, and I think we're looking Andromeda.
Yeah, probably the.
Dwarf galaxies around Andromeda. Okay.
Yeah.
Okay. Yeah, so I typically observe about 7 billion light years back to about 12.5 billion light years back. So all the way from about halfway to the edge of the observable universe to the first galaxies in the universe. So I use galaxy clusters both for studying how galaxies interact, but also as gravitational lenses. So magnifying galaxies behind them so that they're bright enough for us to see, because even with incredible technology, incredibly big telescopes, an incredible site like Maunakea, you still have a hard time seeing these very, very faint galaxies. And so gravity can act as a lens and magnify galaxies in the background and help us out to detect these things. So that's what I do. And I actually, so that's my research passion. I'm guessing that some people on this call have seen support astronomers, and our support astronomer came on tonight.
Yes.
Okay.
Rita.
Rita. Okay.
Yeah.
Okay. So yeah, so I facilitate I facilitate a lot of observations. So I will observe on Gemini both for my own observations, but also for other people's observations. So we don't do like classical nights like we're doing right now. So where a principal investigator of a program comes in and does a guest observation, but we actually take the observations for people. So we help them set up those observations in the daytime, and then at nighttime, we take those observations. And so that can be any science imaginable in astronomy. So we look at things all the way from, asteroids in the main belt, the solar system, all the way out to 12.5, 13 billion light years out. And so a little bit different observing style, and hoping that at some point we'll have Shadow the Scientist sessions there, and we can enjoy the frenetic, wonderful chaos that is complexity that is Gemini observing.
It's true. It's true. It's so true. I think we're during this session, I'm going to drop the links in my journal. It's the key scheduling.
And Aaron, I see you're on the call. I don't know if you're there, but I've interacted with Aaron a little bit over email. So Aaron, I think, is interested in working with some of the staff at Gemini, in particular Julia, who's our wonderful GMOS instrument scientist there. And she's a super awesome black hole lady.
Say hi. Going in there.
Understand.
So glad you joined us.
Yeah, I'll be around.
Are you all on the tour? I know we're on the call. I know we're at Keck. Have you all do a virtual tour or just be inside?
Well, the first couple of nights, we kind of walked around and all the laptop. This is how it is.
You're welcome to.
So the kids from Future Hope have been a revelation. They've been absolutely a revelation of this. Not here today, but they've been amazing. They made it all worthwhile. I don't know, not like it wasn't worthwhile before, but it's been. They've made it quite an experience for us.
Yeah.
So what are we seeing right now on the screen?
So this.
Yeah.
Oh, sorry, you guys. Okay. So this is
Okay.
This is the guided camera of the DEIMOS, and sorry, is this the guide? Yeah, this is the guided camera of DEIMOS. What am I saying? It is, and normally when a DEIMOS slit mask goes in, it goes where my hand is, right up there, all the way across. And it's made of aluminum. It's not very shiny. So when you look at an image, that top part looks darker than the bottom part. But this part is a mirror, properly silver. Now, this is a very special slit mask, not a standard DEIMOS slit mask, where it's mirror. It's actually silver. Sorry, that's why the night sky looks at equally bright in the top and bottom. Okay. So they're both mirrors. This is a mirror. This is a mirror. This is a changeable mirror. It can be moved out, and another mask can be moved in its place. But it's got 5 cuts in it, 5 slits of different weight. We're using the narrowest one to take spectra of bright stars. This is a Gaia target. This is one of our assembler stars. These are currently binaries that he's monitoring. So I'm not sure what the science is that he's doing with these, but occasionally he's switching over and getting spectra of PS1.
Russia, this is LVM. So it's
LVM, let's see.
Yeah.
We're using the points. So 0.7, 0.9, 1, 1.2, 1.5 really weights.
Yeah, okay.
Because these stars are bright and we want to get the highest possible spectral resolution. We're using the narrowest stick. But the stars sort of look like hamburgers when they're on there. Their seeing is worse than 0.7. And if the hamburger is symmetric, you're getting maximum possible light.
So what are the conditions like tonight?
1.5 magnitude extinction, which is was better than being shut down. So
Depends on your science.
Last night, the primary science got shut down for the second half of it. And tonight, the primary science hasn't kicked off at all because of so the primary science are these. So this string of 8 nights, 4 to 11, 2 to Dan, and 2 to Marla, are looking at dwarf galaxies in the local group, some around Andromeda, some behind Andromeda, some closer to us than Andromeda, but all aimed at looking at faint stars associated with these galaxies to measure their chemical composition and diversity. So just to give you an idea, and 18 is 4 megaparsecs, so significant 3 megaparsecs, so further away than Andromeda, which is 0.8. And Evan got 10-hour integrations. And that's in very good. He was using a 1200 for those. Then, so they've been observing some of the satellites with 1200 if velocities are the main thing, velocities are also dispersion. Been observing with 600 if velocities.
Okay. So 600 doesn't have a good resolution for the velocity, the kinematics.
Just because they have very low dispersion in systems. Yeah. So we observed 2 masks and 18 the first half of the night, each of 4 nights, 2.5 hours per mask. So you can imagine the targets that faint, you could spend all night tonight doing it. If your scientific returns are low, so might as well go after the right targets.
What's it? Sorry, what's the magnitude?
21 to 23 in
Okay.
G.
You have to get a fairly high signal noise for the.
Metallicity especially. But also these stars, in these low metallicity systems, they are, sorry, in these low mass systems, they're also low metallicity. The red giants are not very rare. It's a weak, so so it's pretty hard.
Yeah.
In our splash survey, the faintest
Exposure complete.
Okay. Yeah. So with 10 hours, 23 magnitude, you're getting like pretty decent signal.
Yeah,
noise
so
per
I
resolution.
was just, I was in touch with Evan earlier today asking whether we should, the original plan was to put some of his masks on my nights, the beginning of the night, not needed anymore. As an absolute piece. Now, my 2 nights, we are looking at the disk of Andromeda, and we're looking at the satellite superposed on the disk M32. So it's still a satellite program, part satellite, part disk program. My program is somewhat different from what is special about these galaxies that have been targeted here is they also have
DCD readout complete.
I'm so just email. Take care. Good night.
For Maunakea.
Yeah, yes.
Okay. And you're gonna take your car? Are you sure? It's 2-wheel drive. Roger, you should let me take
They
you.
actually might not let you go. A lot of times they don't let you go.
Beyond the
They won't let you go to the so you have to go.
I didn't realize you were gonna use the vehicle that you in.
Yeah, I mean, they usually.
So technically, they're not allowed to say, but they move very, very strong.
Who is the
The Ranger stores. Yeah. So again, I'm happy to meet you guys up at the biz. I have all-wheel drive. I've been there many times.
happy to meet you.
I'll flatter myself to say I'm an expert driver on Maunakea.
Happy to meet
Yeah, a
you.
little bit below expert, but
I'm happy to meet you there, but I know you have.
Yes, but I can also do the drive. All-wheel drive.
You enjoyed us.
I wish I could. I'm supporting my friend who's a plant biologist at her. She has a presentation tomorrow. So I'll be
Of course, very last minute.
it's for the last year. Thank you.
John wrote back to say that it's too late to organize something for that.
Yeah.
They're going to say, are you sure?
well, I would gladly defer to you.
Yeah,
I mean, it depends on your guys' timing because I have to take these to the airport. So
It might, yeah, I think that would be safest. I really like, yeah, I think I'll go home, like, you guys.
You sure? Thank you. And then before, so we'll drive from here to, it's okay to drive from here to the.
Yeah, that I can do it.
HB. It's connecting.
Oh, that's me.
Oh, good. Okay. We'll start people from here at 11 and getting there by probably 12:30. And we'll be after my.
Yeah, probably take about 10-15 minutes of the.
We'll find this half an hour.
Half an hour is kind of, they suggest. I usually stay about 45 minutes if I can. It does make a difference. I went up pretty quick last time I went up, and it was a little bit more difficult for me.
Some people want to get back there later than 4, so I think that'll be fun. Thank you.
Send me a message when you guys are leaving, and I might just come up and meet you guys just for fun.
Okay, we're thinking 11. We're thinking 11.
Any chance I get to go up? Pretty much. Deborah won't be joining us though.
No, of course.
7 months pregnant and
No,
and 14,000 feet don't do it all together. Yeah.
Deborah's just been amazing to us. She's so patient. We're giving her parenting practice. We're asking silly kid-like
That's
questions.
good. I approve. And I will also agree with the statement that Deborah's. It's very common.
So if anyone's interested, I am not audible.
You're,
Oh, that's right, okay. So I'm dropping in the chat a link to the Gemini virtual tour. I'm muted.
Call my mom because I'd rather take her car because my car doesn't have air conditioning.
No problem.
Yeah, so I just dropped the link.
I want to take your kid.
Feel free to explore it. Drop the link to
I didn't even know about this. Okay. We're doing a virtual tour.
Oh, yeah.
So these are the things you don't get over on the PSYOP side.
Oh.
Do you want to share your screen with the group? I can stop sharing.
It's.
Oh, cool.
So I just.
Oh, you did that. So-
And this is, we actually have a new virtual tour that will be out in 2 weeks. We will have that one published soon. But this one will allow you to kind of see Gemini Observatory, and you can actually see Keck in the background, and to just kind of explore all the areas of the telescope of the facility. And definitely feel free to ask questions if you'd like, especially Aaron, since you will be working with Julia and Brian, which we're very excited about.
I'm laughing, Jamaica, because I being a scientific staff member for the last year, the pandemic has prevented me from seeing the actual telescope up there, and I didn't know that we could take a virtual tour through Gemini, so I will definitely do that. It should be part of our training during the pandemic. I'm surprised that we didn't get that as part of the packet.
Yeah. Well, hello, the virtual tour, Brian. We do have one at Gemini.
Yes.
Yes, it does exist. And Joy Pollard did this, and she's doing the new one too.
Oh, nice.
And yeah, it is fantastic. I do this at all of our outreach events, and it's a way that I've learned about the telescope for sure. And there's still so much to learn. So definitely, please feel free to explore, and especially Aaron, we welcome your questions.
Yeah, but this is great. This is something that we could do, when there's downtime, right? Shadow the Scientist session, to be able to show people inside.
Yes.
Walk through.
Yes, I added here facility tour for that.
Yeah, and Jamaica, we also talked about with Andy and Oscar today about doing like the staff profiles. So like having we talked about that like originally. So like doing like the interview, with Brittany for Q coordination, or some of the SOSs for what their general jobs are, just like the life of the observatory, because we have all these things that happen during the day that allow us, the day crew, that allow us, the IT people, that allow us to do the things that we do at night. So I think that would be a really great idea. And Andy is all about that, because he said it came up in another context, which is that we have these kind of interview things on the Gemini website, but these are all from a decade ago. And a lot of the people that were there then aren't there anymore. And some of the roles have changed quite a bit. And yeah, even like, the pandemic has brought about different changes to the way the observatory life works. So
that's true.
Yeah.
And there's bad weather for the way to those things. But the other thing we're discussing with Debbie today is if someone as a TO interrupts, sort of is proprietary and sort of sensitive in this sense, you cut away and say, sorry, the telescope is doing something that is not for public consumption. And then we're going to cut to show you staff profiles. And we're going to go to commercial places.
Yes.
you want to take my chair?
No, no.
I'm actually really good.
Nice. No, that's really great. And I was just thinking about how it's been so great just watching how this interaction is going. Obviously, Jenny notes on how we could do this flow and things we could add into it. But I really liked how you started off with really engaging participants first.
Sometimes it's hard to do when you have 100 participants. If I read you honestly,
Yeah.
well,
Yeah. I think we had like 200. That was like right after Don't Look Up came out.
Yeah, people probably were. Leo DiCaprio and Jennifer Lawrence. Yeah.
Oh, we didn't get invited on the merch.
I mean, who wants to go?
I think that was the lesson of one of the lessons there.
So instruments. Air conditioning.
Oh, thank you.
I'm dropping a link in the chat to our current instruments on Gemini, especially Aaron. Julie works GMOS, right?
She is the GMOS master. Yeah. Yes. She's in charge of everything.
Yes.
And she is very, very good at it.
Wonderful screen on there today. I was out of my music was really but I didn't get a chance to see if she had some fire function.
Yeah.
She was supposed to be running for lunch.
Yes.
I think she would call me because I read. Yeah, I think.
So Stefan's project, Kevin's project, this project of salvation will be doing child scientists on the 30th of September. Okay. I'm wondering from is it the 23rd, 1 week from that? So Friday, Saturday, which is those are normally those are great nights for kids at 12 and school the next day.
So, so you work with Maunakea on this project, and
Yeah.
these are like observations. So okay, good.
It's called salvation, stands for spectroscopic analysis of luminous variables and timescales.
So that
Oh.
it's not even a torture document.
I'll be able to, I'll remember it eventually.
We also have an acronym called pulsation, which is photometric understanding of given stars and timescales.
Yeah, our neighbors are all.
Our neighbor is always good.
Yeah.
Transients in our neighbor gives you a TI.
As far as astronomy acronyms go, that's
Pretty high up.
pretty high up. Yeah.
Exposure
A lot of them
complete.
are
Yeah, there's the LIMS survey where the E is extraordinary. Some survey extraordinary is the galactic something. It's a galactic mid-plane survey. LIMS.
I had a friend in grad school that he was a gravitational lensing person, and he got so tired of people making like tortured acronyms that he made an EIEIO survey. EIEIO. And it was just a bunch of words where he randomly capitalized letters. It never took off. I don't know why.
Mark Dickinson had an acronym called FISWAGA, FISWAGA, and it stood for Far Infrared Survey without a good acronym.
DCD readout complete.
That's what the half of observing nights are for, right?
Bad weather nights.
I think or else was made on that whiteboard at Keck II.
Give us tech time or else.
Come up with a better.
Or else we'll come up with the worst acronym.
So for those of you in the chat, I've dropped a link to the Maunakea Weather Center. That's where you can see the webcams from the various observatories. These are the cloud cams, but it will allow you to see the current conditions on the summit right now. I would share my screen, but my connection to the Wi-Fi is. Oh,
You can share.
yeah.
Yeah, I'll stop sharing.
I got it. And then we'll put the
In fact, this will allow me to check something very important, which is how is our software running? Type it. Still running.
Okay, here we go.
Still running. Look at that. Still running.
Oh, perfect. Thank you. And I can just.
Oh, yeah, there you go.
Yeah.
On the screen.
Okay, we're done.
Yes, you're absolutely right.
There's
Yay. What did I do?
That's your week's the other
Oh
paper.
no,
I've done that.
It's fun. I'm gonna use share. I think I reacted to that happened. We can fix that. Share screen.
Still running.
There we go.
Yeah, so Brian was just saying we can actually see some clouds for sure right now. And this is part of the reason why I really like sharing this, because the environment that astronomers have to work with, the weather really is so dynamic and can change at any time. And so this really allows anyone from the outside to see what our astronomers, what the scientists are having to deal with as it's actually happening. One of the things that can cause us to, all the observatories, to have to close for a bit is having high humidity, rains, any of those. The certain humidity can cause the telescope to have to close. Now, Gemini needs to be below 80%. What is it for Keck?
Also relative. But they also look at gradients. They look at how sharply it's going up, and if it's going up very gradually, they sometimes allow you to go above that. But they're really they pay attention to how rapidly. It's a question of how much time you have to close it.
Oh, okay. I didn't realize that.
But they go by, not, if I remember correctly, Rita would certainly be the expert on this. I think they go by temperature differential between the dew point.
That's right. Yeah. So on the X-Men, so you'll see the green indicators, yellow indicators, and red indicators. And it's I think that those differentials are 2 degrees.
2 is what I remember.
4 by.
Yeah, 2 is the critical one where below which it has. Yeah. Now, for you islanders, let me ask this question. Picked up these, and they say contains quinine. Every one of the sparkling water things I could find it. I don't have malaria. I don't want to eat quinine, but they all say it contains quinine. Right? Have you noticed it?
They don't have it in the Diet Coke, so they can.
It's not an astronomical question, but I still have to ask about malaria.
I have definitely noticed that tonic water here, definitely. But it's not very much.
Yeah, it tastes fine.
Yeah. Oh,
Maybe
okay.
you could show our Gemini cloud cams. Like one thing that I really like to show on Shadowless Active Sessions is the quick flex page. So where we show like normally it's like the SIVA, and then we show all the different cloud cams all at once and it updates.
Oh, I don't.
You know that?
I don't know that.
Yeah, that's the one that we're usually playing like on the observatory.
Sure. I don't know. Yeah.
Yeah,
Sure.
this is super cool. Okay, I'll take that as a challenge.
Deborah has told us how to start this software, reduction software. And it's literally been running since I met her at what, 4 o'clock, 3:30?
How much data is it?
It's one mask.
One mask, how many observations?
Maybe 5 or 6. I don't remember actually. 6 exposures, individual exposures. That add up to about 2 hours.
Okay.
20 minutes. Seems reasonable. Just under 20 minutes multiplied by 6.
D2 pipeline would take depends on what you do.
No, so this has been running since 4 p.m. So, but I'm curious because this is one of, this is a fairly well-populated mass with 200 slits.
200 slits.
Yeah, it's in the center of 133. So.
Wow. Okay. My record is like 170.
So this is these are minimum slit length of 3.3 arc circuits in crowded regions.
So I think this takes a lot of bandwidth to run.
Yeah, this one was working pretty fast, but maybe oh, there we go.
There we
So now you're showing me something new.
Yeah, we're trading industry secrets here. Yeah, so this updates, like, so it gives as many frames as you join 4. So it will do, let's see, for the last 4 minutes or so. So this is just the sky moving over the last 4 minutes. So going up, and then you have the clouds. You have airplanes in the background of the North Camp. See, actually, Waimea is here.
Scale image means it's an old image from a long time ago? Or what is it?
Yeah, sometimes when there's humidity in the camera can't deal things, there could be a connection loss. Normally it's not a problem, that was just a glitch in the camera.
Yeah, okay.
And then yeah, you can see Hilo down here. So covered in clouds as usual. But a lot of light.
Thank heaven. Well, if it weren't covered in clouds, it probably would be more light.
And yeah. And then the South Cam and the South Summit here, IRTF and West Cam. It's open. And actually this is Keck II right here. So on the North Cam you can actually see what works with it. And one of the coolest things that I've ever seen on this cam, because you see it's so light sensitive. So there's so many cool things you can see, but actually the coolest thing I've ever seen was not in the sky, it was on the ground. So it was when Kilauea erupted in 2018. And so
Aria's joined. Sorry.
So yeah, this was December or so, 2018. May 2018. It might have been a new eruption or something. But it was, I guess it was no, we were living in Santa. So it was this.
We went all the way to August is when it started first time.
Okay.
Yeah.
And then it went off again December.
Yeah, that's right.
Yeah. So we were observing, and it was me and my wife that were observing, and I was paying attention to the observation. She was like looking at the cloud cam because it's like mesmerizing to look at. And you see this like giant plume of smoke that came up in the Hilo cam and the South cam. And she's like, I think something just happened. And we were in Santa Cruz. So we were living in Santa Cruz at the time. And we were like, holy crap. And so then we went on the USGS site, there was a earthquake. We were like, okay, that has to be the volcano going off. And then about an hour and a half later, our support astronomer came on, like woke up, came on and was like, hey, so Holly, my mom just and Deborah was like, I
We ever have to close the
no, because it blows the trade. Yeah. Exactly. Yeah. So Mrs. Maunakea. Yeah. So yeah, there's never vlog on this part.
That's a really good question. I never even thought of that.
Yeah, because that would be devastating, right?
I used to live in
Yeah. Yeah, totally. Yeah, it makes a big difference. But yeah, that was so cool, and it was just this pillar of like fire coming up in the Hilo cam.
I remember looking at the observatory closest to EQI gets to 1250. Well, we were living in that for about 3 months straight.
Yeah,
it was 150 to 200 for about 3 months. Volcanoes really pumping up.
Was it really that bad?
Yeah.
Wow. Okay.
I actually have the 2020 eruption. So we did a nice video on it and put it up on the YouTube channel.
Hey, Aria, welcome back. I missed you.
readout complete.
We were just talking about you as I think you're the record holder for a number of Shadow the Scientist sessions attended. So welcome back.
Thank you.
Thank you. I'm glad to be back.
You're in a new grade now than when you started. That's how long you've been taking part in Shadow the Scientist, if I remember correctly. 10 to 11, is that right? Grade 10 to grade 11?
Yeah.
Wonderful. So we'll be on for the next few nights. Tonight's Friday, so next 4 nights we'll be on. Please join. There'll be we've been thinking of you. I'll tell you in the following context, because you and a few other students, high school students mostly, some college students, have taken part in Shadow the Scientists, have really come to learn different aspects of astronomy, and we'd love for you to be near peer mentors to students who may not have the same level of experience with astronomy. This is something I was meaning to reach out to you and talk to you about, but since you've connected today, this is something I wanted to run by you. Of course, it shouldn't come at the expense of your schoolwork or any other activities that you are already engaged in. But I think you'd be a terrific near peer mentor with anything related to telescope observation or astronomy. We're thinking of setting up sort of this some kind of credentialing system for Shadow the Scientists, where literally this position that would be a, not one, but multiple near peer mentors. And Anthara would be a great, another great near peer mentor. He's just started college. And why don't we go around and you know some of us, you don't know others. Would it be helpful if we introduced ourselves, Arya? You probably, I don't know how well you can see us on the screen, but
Oh yeah, that's us. Yes.
so yeah, please go ahead, Jamika, please introduce
Oh,
yourself.
sure. Okay. Aloha, Arya. My name is Jamika Marshall. I'm an outreach assistant at the International Gemini Observatory. And I am excited to be working on the Shadow the Scientist program with Brian. And Brian introduced me to Raja and this amazing group. I have heard a lot about you, and it's so impressive how well you've been participating in it. And I tell you, I'm sure you could teach me so much, Arya. So I am definitely looking forward to following in your footsteps to attend a lot as much as I can.
Thanks, Jamika. Go ahead, Antara.
Okay. Hi, I'm a sophomore in college. I go to physics and other things, but I've been working with Rajan for 4 years now. And yeah, most of my research has been about characterizing particular kinds of stars in the Andromeda galaxy and the Triangular galaxy. But yeah, it's been a very, very interesting time. And I have also heard about you, and because I remember you mentioning Arya, and a bunch of people.
Yeah.
But yeah.
And Antara has already been a mentor in the Python programming we teach. So that's something that Arya would love to, you've taken that class, I think, right, Arya? Haven't you taken the PR tutorial? Arya, I'm trying to remember if you have. Arya, have you taken the Python programming workshop that we offer?
Yes, I did.
Yeah, okay. So that's what I thought I remembered. And Antara has been a mentor for it. She's screen shared. So you probably saw her on it. Thank you. Brian is not going to be a near peer mentor. He'll be a mentor, but not a near peer mentor. Sorry.
Depends on my peers. Hello, Arya. I think actually, Arya, you came to one of my sessions, and maybe a couple of my sessions. So I've been working with Raja on Shadow the Scientist. I'm a scientific staff member in the science operations division of the Gemini Observatory, so the same observatory that Jamika works for. And he might have come to, so I do astronomical research as well. So I both facilitate research for other people and I do my own research. And so I regularly use Keck, I regularly use Subaru, Gemini, Hubble Space Telescope, and I think you came to one of my sessions on galaxy clusters. Distant Universe for Subaru, or maybe for Keck. Am I remembering right?
Yeah, I did.
Okay, great. Yeah. And yeah, so we're trying to run Shadow the Scientist for Gemini, which is a Q-based observing system, which is very, very different from the kind of classical nights that we have. So we do, you know, all different science on a given night. We use tons of different instruments. And so we're here at Keck learning from the master, from Raja, on how to I don't know, search the heavens and talk to people about it.
Okay. Oh, hi, Arya. I'm Stefan. I think I've seen you at some of the previous Shadow of the Scientist sessions when you're doing the salvation research with the Lick Observatory. I think you were there for some of them last year, I think it was, or earlier this year. But yeah, I am a graduate of Willamette University. I went to Kona High School here in Kona. And I studied physics, and I'm now working with Raja and the Salvation team. I'm doing some research with him, and I'm hoping to go back to graduate school at some point. But I'm kind of like building my resume and my CV to get some experience. Yeah, in the process of getting back into school.
It's a good place to get experience.
Yeah, definitely, especially for this stuff. Like nowhere else is better to go. And then like I've always wanted to work in astronomy, and like since I've grown up here, I've always thought, you know, it would be a really good place to do astronomy, live at home. So it's really hopefully it would be a nice thing to get a job here eventually and live at home.
Absolutely. But I know that would be what was wanted.
Yeah.
That would be what's wanted to bring you back here.
Mhm.
Did you do the Akamai?
I was just about to ask that.
Oh,
No, I did
nice.
not actually. I was a little late on the application. I didn't hear about it till too late. But I basically worked when I was working with Andrea. It was basically like a pseudo Akamai project.
Okay.
With Andrea, and he was Matt, the computer tech at CFHT at the time.
Okay.
Yeah.
Okay. Nice. I was thinking about Akamai for Aaron. If
Yeah.
you-
Yeah, a couple of my friends have done that, and they've loved it, and they got really good jobs out of that program
Yeah,
too.
no, it's
so-
an amazing program. It's for sure. It's very intense.
Yeah.
Very intense. I served as a co-mentor for one of the Akamai students this summer, and man, oh man, did that move fast. And it was wonderful, and the student was absolutely amazing. But it was me and Emma that were co-mentoring him.
That's true.
Yeah, it was great. He gave a great presentation. He got some Lyman Alpha halos. Thank you.
Yes, please.
Lyman Alpha halos around high redshift quasars.
Oh, I'm so sorry.
Oh,
I'm so sorry.
It's okay.
I had no idea that we were the pandemic.
No. Oh my God, that's so good. No worries. It's not
He knows where things are more than I do.
fun. It's so fun. I love pickles. I love pickles. We used to put, peppermint sticks all the way down into, so we get fat pickles for the can thing. Good. You put a long peppermint stick inside a fat dill pickle. It's so good. It's so good.
Oh, it was what was going on? It was just like pickles, and I'm sorry.
May or may not have had a slight
Yeah.
spillage incident.
Roger might have spilled some pickle juice on somebody. Yeah. It wasn't on the computer. And I was reading and I just, I'm sorry. Yes.
Everything is okay now.
We're
Oh my
good.
gosh, thank you so much. 'Cause I do. Thank you.
This is a much better system of delivery than what I did.
And
And I got some on you. I'm so sorry.
so great. I needed to pick me up right. Great. Thank you for sharing. Oh, do you know, they may be interested, especially Aria, in hearing about the new kind of star that you've been looking at, this different classification. Mhm.
Okay, so I'm going to share my screen. Actually, I think that was the.
And Arya, come to the SIP program next summer. You have
I'm
to.
gonna keep that with the SIP link in chat. Well, I have it. There we go. SIP. I know Manas, you're in the Bay Area, and Arya. That is the SIP link for you. And I can absolutely tell for God.
Arya, you should be a mentor next summer for SIP. You can be. Could you be?
Yeah.
But then we'll move on to some other phases of HCN or some other project.
Yeah, I'm just trying to pull up a good spectrum because I have a normalized spectrum that I want to find out.
The overleaf document has some.
Yeah, and I'm on the
No, the overleaf, okay.
taking a minute to compile because I dumped a lot of graphs in there.
Thank you, Brian.
Yeah.
I appreciate it.
Okay.
Let's do it again.
Yeah.
Look for the big-legged friend.
Okay. This might. I'm going to share screen on this thing. Okay, so that is a spectrum. We'll get the internet.
GCD readout complete.
Basically, the kind of star that I look at is, okay, maybe I should start with cyanogen. So stars contain elements in various proportions and things, and what we're looking at is,
It went out.
I thought someone was asking the question.
It was like huge cockroach.
Okay. So
You see it out there? Oh, it was inside before.
I'm going to okay, so the molecule that we're looking for in the stars that we're looking at is called cyanogen. So when you have carbon and you have nitrogen, you have one carbon for each nitrogen. You have this molecule that's called cyanogen, and it's got this very specific signature when you're looking at the spectrum of the star, which you can do with instruments like the Keck telescope. So when we look for cyanogen, when we have stellar spectra, it shows up as this very particular W shape in the spectrum. You can see a pretty strong W. I actually have a spectrum of the carbon star that I'm going to pull up because carbon stars are a kind of star that we know has very strong. Oh, I don't know what I did there, but it was not what I wanted to do. Okay, there we go. So that is a spectrum of a carbon star. And you can see that is, we've zoomed in on the spectrum. That's not all of the spectrum. That's from a wavelength of about 7,800 to 8,200 angstroms.
These are absorption features. So they're very broad.
So yeah, it's like, I have better spectra. I need to update all of these, which is why I was running.
What is broad? What were you saying is broad?
So it runs from these are absorption features or
Molecular bands.
molecular bands. Okay.
You can see these very sharp, gradual, sharp, gradual, sharp, gradual. That's those three or four of those.
Yeah.
On the left side of the W.
What is their wavelength range?
7,800 to 8,200. So carbon stars have a very prominent W feature. And then there are some stars that just don't have this feature at all. But the kind of star that we're looking at, which is the thing I was sharing beforehand, it has a W feature, but you can probably see that it's not as distinctive as the carbon star W feature. So we have a cyanogen feature, but
And they're all in the same units that you're plotting.
Oh,
Right? They're
yeah.
exactly the same shape. We're using exactly. And the vertical axis is 1 to 2,
Yeah.
right? Or point,
It's
0.5 to 2. Okay.
Yeah, I think.
Yeah, go back. You'll see exactly the same scale as what I remember.
I can go back. So yeah, 0.5 to 2. And you can really see how dramatic that changes. But we found this kind of star that has a cyanogen feature, but it's not super prominent. And it doesn't seem to have any of the other chemical features associated with carbon stars. It seems like oxygen stars are in most respects other than from the CN feature. So we called it a weak CN star because it has the cyanogen feature, but it's weak. And we are trying to characterize how this population of stars sort of formed and evolved. And so we have stuff like we're plotting isochrone.
Sorry, what was that word?
Isochrone.
Isochrone.
So there's a,
Let me pull up.
these are, we make a model. Yeah, they use.
Yeah, so isochrone for, I don't want to be throwing. If you have an isochrone, so the iso in isochrone means same, and the chrome in isochrone means dyne. So let me try and see this because we have yeah, but all of these are, we're plotting track.
No, isochrones, these are all isochrones.
We're plotting isochrones. So each one of these is plotting for a particular age, and the log of that age is on the. So, wow.
So if I can just jump in for a second, can you see my cursor? No, you can't, right?
Yeah.
No, but
Oh,
yeah.
okay. If you
So
want, you can.
yeah, so what happens is when you take a bunch of computer models of stars, and you start them all off at the same time. That is, you have them be born at the same time. But what's different among the stars is how massive they are. So the most massive stars spend the shortest amount of time on what is called the main sequence, where they're burning hydrogen into helium. And in fact, in this graph, you can see that these things, where's the cursor? Yeah, so that these stars here are very young stars that are actually a continuation of this line. They would go through these but if you wait long enough, these stars evolve away from their pure hydrogen burning in the core. And as you wait longer and longer, more and more stars peel away from that. And that's what you're seeing in the sequence. These are isochrones of different times. The lowest isochrone, most of the massive stars have peeled away from this main sequence, and they're all on the red side, they're red giants. Using diagrams like these, we've shown that the Weissian stars are in the mass range 5 to 10 times the mass of the sun, and they've evolved away from the main sequence. So, you know, anything in a light color in this diagram is a Weissian star. Lighter, no, dark purple are carbon stars. Huh?
Yeah.
Oh, they're Weissian. Oh, gotcha. Purple, yeah, more purple and white. Purple. And you can
Sorry, the scale bar here, please.
it's a yeah.
Okay. I'm going to fill up the comment box because I need the comment box. So what we did was we had and we made Doppler spectra for the CN and stars by just adding together a bunch of the spectra for the CN stars, and then that was like 100 stars. Annually, okay, the CN feature is here. But we had maybe.
I know that work. I had to do it in Roger's office as an
Oh,
undergrad.
I appreciate
Well,
that.
had to in astronomy. I volunteered to.
Yeah, but we basically automated by comparing, so added together artificially classified stars, made a Doppler spectrum, and then compared all the science spectra through the doublet, and then calculated the visibility.
Okay.
And what we did
So
was,
that's good.
yeah. Yeah. So
And COMET is an acronym.
COMET is, well,
COMET
it
is an
was
acronym. It looks like a comet. It is a acronym.
It was a acronym.
So I have to come up with an acronym for this
We
thing
started calling
because it looked like a comet. Like a
It
comet kind of thing.
does.
So it's comparison to empirical techniques.
Wonderful.
Yeah. Yeah, we're plotting against the weeks, yeah, on the x-axis of the compare.
Okay. That's very good.
Yeah, but basically there's this very strong cluster in
Okay,
here.
I see.
So we picked a point here and calculated the distance from the heart of the comet and weighted the stars on the CMB with respect to how far they were from the heart of the comet.
So we did something like e to the minus distance divided by d naught. And so the closer it is to that line, the higher the number it gets. So in other words, what, let me just back up and say that, carbon stars are a distinct class. You see the red points in the comet plot. Or in the comet plot, you can really see that they're distinct from everything else in terms of their properties. They're a separate population, right? Red population. But the weak CN stars,
because they have a low score against the
carbon stars,
Yeah.
and they have a very score against the
Exposure.
their features are
complete.
too strong to match the weak CN term. Whereas normal stars have too weak, they don't have any weak CN, so they're too weak to. So
in this case, a low score means similarity.
yeah, it's chi-squared. So it's, so it's a low chi-square. So what you can see here is carbon stars are a distinct set. They've been known for a while. They're sort of seen as this anomaly where dredge up is going on and carbon is being brought to their surface. The weak CN stars, interestingly, look like the tail of a distribution. They're not separate. I mean, there's no daylight between weak CN stars and everything else. They seem to be the end of some distribution. That's strange, and we don't understand. We're sort of working with the world's experts on stellar evolution, Leo Girardi and Paolo Marigot. They have no idea why they're doing this, right? So, but we'd hope they would say, aha, this is what's going on.
GTB
Let's write a
readout
paper. But
complete.
we're writing about papers say, we have no idea what's going on.
Okay.
So
that's fun.
So that's the color, is the closeness.
I got it. Okay, so I was actually going to ask how you differentiate between the carbon stars and the weak CN stars, but this is exactly the metric that you use, because the two plots that you showed, I mean, yeah, there's this, this obvious strength difference between the two, but the features are more or less the same.
Yeah.
Ish.
So if you think in terms of the W, what happens is the whole class of stars that have this very steep W, they're a rare population, about 2% of the population have this very strong W, and then everything else has really weak zero. And people used to assume it's all zero, everything else. You either had a W or you don't. And what we've discovered is, no, there is a faint version of a W, and there's sort of a continuous distribution. I mean, these are weak CN stars.
These are all weak CN. They have other features which are very much not present.
Yeah,
so titanium oxide.
Titanium oxide, carbon trip, carbon.
So the calcium triplets not in
very weak in carbon stars.
Oh, really? Okay.
Yeah. If you should,
I thought that was
we have a carbon star plot like this, right?
We have a carbon star.
Plot that's just like this, a template like this. Yeah. You can't see the calcium triplet at all. That would be at 8500.
And the empty parts of the spectrum are the A and B.
Yes.
What?
Atmospheric absorption. Oh,
Yeah, we talked about this a little bit at our session, the telluric bands. So yeah, this was also for near-infrared observations. So we take the telluric stars, and this is exactly, basically the data is censored there because you can't trust it as much. Right?
Yeah, we don't do any telluric correction until we're showing off spectral features.
Yeah. So you have the absorption from the atmosphere, and that changes as a function of night, as a function of where you're looking, so on and so forth. And so that is not an intrinsic part of the spectrum.
Right.
And so you can either try to make a correction for it and have the hubris to do that, or you can take you could do it semi-empirically. So you can take a model that's based off of some sort of observations, and then you say, okay, I'm going to make this correction. You can observe a standard to do that, which is what we do at Gemini in the near infrared. Or you can say, well, forget about it. We have enough data elsewhere, so we can just kind of throw that part away and then do the cross correlation. So I guess that's what you guys did.
Yeah, we lose so much signal noise at that part of the spectrum. I can't really use that. Give up on it. So these are all plots from a paper that we're actually writing two papers. One on the discovery in the Andromeda galaxy, and ironically, we're comparing three galaxies: Andromeda, Triangular, and the Large Magnetic Cloud. They're very difficult to see in Andromeda because they're rare, subtle, The other two galaxies, they're increasingly more prominent. So, as as these twists and turns happen in life, we found the most difficult thing first. And it was just, and then we went to the easier cases as clear as day. Why didn't we stumble on these first? Because then it wouldn't have taken us so long to find them. We found the most difficult case first, but now it's very clear that they're there in other galaxies. That was we initially thought might be some anomaly in one galaxy, like Andromeda, but no, it's not it's there in these other galaxies with even more power.
And so you're writing this paper together?
Yeah, first name is on the.
I can go and yeah.
Oh, yes.
Yeah, no, I'm on the overview, but I'm not, so I'm going to go to Google.
Yeah. We were just working on it in Cambridge a couple of weeks ago.
I need to make some. I have realized that I just a lot of the plots
Are old, yeah.
I need to do this, which is what I was going to say. But yeah, that is the paper.
Oh, look at you. There you go. It's great. Wow. Wow. I'm trying to scroll up on my screen, which is not going to work.
It does get a little bit confusing, doesn't it?
Yeah, there's a lot of insert stuff here.
No.
That's how things are made. Yeah, I was just doing this with my student today. We were writing a paper together, and it was basically really nice, well polished sections followed by red, insert the plot here, insert. So.
No, it goes from semi or to just there's nothing.
Yeah. Well,
that is that I need to talk about.
Wow.
But yeah.
So impressive. So is this in LaTeX?
Yeah.
But it's what collab is.
Overview. So it's just we're writing it in overview is just the thing that
it's a shared platform.
Yeah.
Oh.
It's like Google Colab, but if you were using.
Got it.
Yeah.
What Colab is to a Python code or any code is what Colab is to that, Overleaf is to LaTeX.
Yeah.
What Google Doc is to Word Docs, Google Sheet is to.
Okay.
yes, this is really common in astronomy. I don't do so many writing of papers like this, but definitely for proposals, this is used all the time because you're always going up right up to the deadline. People are tinkering with things all the time, and so it's really helpful to have this online environment, especially when you have collaborators all over the world. So a lot of times I write with people in Bologna in Italy, and so we're exactly 12 hours apart in the so let's see, in the summer, right? So we're 12 hours apart, 11 the rest of the year. And so it's literally I'll go to sleep, I'll say, hey, Olga, I'm done with the overleaf. It's all yours now. Then I go to sleep, I wake up, and then she's written, an entire section, and then we just move forward that way. So yeah, it's really amazing. And the pandemic made people more willing to have these kind of environments because you can't as often sit down with somebody and do it. So yeah, no, it's been really great.
Yeah, overleaf is great. And just that, and it has a bit of a
I'm sorry.
I think I just asked that to switch to the template. But basically, I now voluntarily do all my concepts in overleaf just to be better. And
it's great for yeah, LaTeX is so great for
yeah, it's very, and I was very bad at it. So
yeah, I think after my second year, all my problem sets had to be typed out. It was a pain.
Yeah,
it looked nicer
nothing
too.
has to beat that yet, but I decided for some reason that I was going to submit my 3 problems at the weekend like that.
Oh my goodness.
Oh,
My goodness. What's wrong with penciling, dude?
I did that.
Yeah.
And then it just kind of, and then I didn't need to submit anything. I didn't need to type up or submit anything. So because either you have test or code.
Okay.
But now I have 2 projects of the week, and one of them has to be like that. The other 2 are like your choice, but I'm just going for it.
Okay. In my last year at Santa Cruz undergrad, when I was in graduate courses and doing my senior thesis with Raja, yeah, I had several classes, general relativity classes, where they forced us to do it in LaTeX. And man, did I fight hard, because I love pencil and paper, and it's so, I feel so much more connected to the work that I'm doing with pencil and paper. And I find LaTeX, like I even didn't want to write in LaTeX initially, because I felt like there's so many formatting things that, especially when you're getting into the flow of writing,
Doing PR too. Not exactly the friendliest things to LaTeX.
No, totally not. Yeah, you're absolutely right. Like, yeah. But like, yeah, as you're like getting into the flow of the writing, then you have to do like $sign, like / like, open brace. And, yeah, I never really liked that. But now I've gotten so used to it that it's just like, Pavlovian.
Yeah, I usually pencil and paper solve my stuff, and then once I have answers, I transfer.
So Arya, very appropriately, right now, you are the only Shadow the Scientist participant, while the rest of us are forced. I think it's very, very appropriate that you are here. You deserve to have a private viewing of Keck. Literally private. You're the only, literally, I think right now, Rita's on the mountaintop, Alessandra's in the remote ops too, Antara, Jamaica, and I are here. The only one.
Private tour of the Antara's LaTeX.
Yeah, it's very badly formatted. I apologize. There could be better tours.
But Arya, do please apply to SIP next year. I would love for you to come to Santa Cruz and do research in astronomy. What's the name? Sorry.
Chris Linkhart?
Chris Linkhart? Yeah. He does. So no, Chris isn't on this paper.
Oh, I saw.
It might have been in the test, but I actually
yeah.
it's in the
Okay,
test.
it's still somebody else.
Yeah.
But he's not on this.
He's not on the paper. He is he's Zooniverse, right? He's Mr. Zooniverse. He started.
Did he start with Chris Linkhart?
Well, Arya said she's planning on applying this year.
Very we'll all be there to cheer you on, really.
Definitely. I know Chris Linkhart from his work with Roger Miller.
Right, so he was at Oxford. He is at Oxford.
Oh, is he still there?
He's with Roger. You said his work with Roger?
Sir Patrick Ward on the
show. So popular, yeah, who's a science popularizer in the UK.
Yes, he's been in the UK. When I was young, I was watching Chris and he was working with Sir Patrick Ward. Now he's doing
he started doing this. He's and this general thing of citizen science is really, the universe is really boosted.
That's what I was working with Andrea, Canada friends. We were doing sort of like citizen science website too.
Really?
I don't think it ever really got off the ground. I think we lost funding.
Oh.
What was it for?
We were trying to create like a Google Maps kind of interface to look at some of the mega cat images, and we were going to have people look and identify AGN stuff.
Oh, really? How were you planning on them identifying?
Basically, you gotta click, and then you look at the nucleus, identify different types. I don't remember what exactly it was. It was like 6 years ago.
Okay.
Yeah.
So it was really from the like colors and morphology.
Yeah, the color. I think the plan was to eventually pull up a spectra of each galaxy.
Oh, that would be cool.
Yeah.
So we use a MegaCam archive, MegaCam interface, a safe HD interface, as our bad weather backup. If we don't have instruments to show, we go over that. This is from the NGBS project, next generation. Arya, the other thing that I think you may have told us this before. You would do astronomy, right? If you came to Santa Cruz for SIP?
Yeah, I would.
You would, okay. What are your hobbies outside astronomy and school?
I'm on the debate team this year.
Okay, wonderful. Cool.
Yeah, I'm the vice president for our school's team.
Fantastic. You know, when you're writing a paper, it is very much about pleading your case and also about really presenting evidence to the contrary in a balanced way. It's actually, you're debating both sides of the question. And this, you know, so yeah, I think you'll find that your debating experience, skills will translate very well when it comes to storytelling for scientific journal articles.
I would also go for conferences as well. So many of the, so I did debate and extemporaneous public speaking in high school. I didn't really like doing it at the time, but it paid off a lot because it allows you to think quickly on your feet, to understand, empathize with another person's point of view, and then try to, deconstruct both your own points of view and other people's points of view, and see where that might take you. And then that's great fodder for your next telescope proposal, or anytime you start doing that, you have the instrumentation to be able to then challenge your own beliefs or challenge other people's beliefs. So I think that's a really amazing part of science, because there is something that you can do about that other than just debate it without any grounding.
So do you do Model UN, for example?
Oh, I was just gonna ask that. I did Model UN
I totally love UN.
and Montreal, and I also did government school.
And it's going to be in person area next summer. Well, it'll be hybrid. You can do part of it in person, part of it from home, or you can do all of it from home, all of it in person.
So Arya said she's actually going to be drafting a proposal for time on one of the Maunakea telescopes soon.
Oh, through Maunakea scholars?
She hopes to be able to state her case effectively.
Wait,
Arya, is this through Maunakea scholars and Mary Beth Leitcher?
Yeah.
okay.
Awesome.
That's a fantastic program. I did Maunakea Scholars with my junior and senior girls 2 or 3 years. They really, it was for anyone, but I offered it to all of my students, but actually it just ended up being the ladies who decided to join. Yeah, it was really great for my students. I had one young lady who did it for 3 years and then went into astronomy when she got into undergrad.
Oh.
And they got time on the telescope?
Oh yes, my students got time every year. Yes, sure did. They got Keck time, or TF time. And we had some follow-ups for like 2 summers. Amber, one of my students who was a sophomore, she did it for junior and senior year as well. And she continuously got time for this one project, but all of my students got time. The ones who submitted proposals, yeah, she did. And then Mary Beth, Doug Simons, of course, really helped so much with that. And that was just incredible. And Andrea Hedrick, and that's where I met her. And she was mentoring me to mentor my students for Maunakea Scholars.
Nice.
Oh, here she is. Aria. So I just want to drop a link in the chat that you might find interesting. So this is so you did the Python course already. You might find this resource interesting. These are our kind of a collab notebook activities. And we host these live. Tina Shiny Cafe is to go. The one that I just dropped is one that I did in April with one of our astronomers, Thomas Siegel. And
GTD readout complete.
And there are multiple Python notebooks. This one, Breaking the Solar System, is one of the first ones that we did. This one I'm the most familiar with because I've done it uh, 4 or 5 times. I just did a couple of workshops for teachers on this one too. But I'm sure this will be simple for you, but it does lots of different simulations. You can scale it up or down. You may find it interesting. And then when you go, I'll drop the link to the main page. We have gravitational lensing, exoplanet searches, and one other thing. But I think it hopefully isn't too simple for you, but maybe it would give you some good practice with your Python skills.
Nice. Yeah, we do.
Thank
Yeah, we do live sessions. Yeah, like with lots of people from the lab. Stephanie Jeannot is also involved in this.
Yes.
Right? Yeah.
Yeah. Actually, I did one with Stephanie too. I hosted her Astronomy Cafe. Sure did, and worked with CE. Helped me with that
Oh,
one.
wonderful. Okay.
Yeah.
Which Stephanie is this, you know?
Jeannot.
Do you know the capital of Alaska? Capital of the state of Alaska?
Honolulu.
Do you know the capital state name of it?
I missed
This
that.
is Jay Leno was going around New York City asking people the capital of Alaska. It was like Fairbanks and he started asking, "Did you know?" They're so good.
I probably would have been slightly subtle for me too. Oh, black holes is the other one, Aria, that I couldn't think of. Black holes is the other one. Send all the things to you.
What are we doing on time?
It is done.
Okay, so we should probably. We should probably stop recording if you can you reach out.
Yeah, sure.
No, it's not in here.
Oh,
Yeah,
I got
it.
Yeah. Stop
Yeah,
recording.